lesson is called complex numbers. And complex you probably thought up till now that when we say real numbers that we meant that's the biggest set of numbers that there is, but it's not, right? The biggest set of numbers is actually called complex numbers. Real numbers are just a subset of them. And they come into play now because of solving quadratic equations. You need different kinds of numbers than the real numbers that we've already been dealing with. And there are a lot of SOL requirements that come from this, right? This is actually the first page of the SOLs that come from this one topic. And I wouldn't bother copying them. Again, this is all posted online if you wanted to get it. We will look at these at the end, and it'll mean a lot more to you than it does now. But all these things come from this complex numbers topic. And so it is important. Now, what we do, the way we deal with it in class, I'm going to show you some shortcuts that you can use with the calculator especially that make it easier. Some of the quadratic formula, when you use it, it doesn't work quite as easy as I really wish. I mean, if it does, maybe you'll figure it out better than me, but I was playing around with it, not having as much success as I wanted. But remember, this was the graphic that we looked in the last section, that based on the discriminant, we could tell how many real solutions that we would get, right? And we knew that if it was positive, we expected 2 real solutions. If it was 0, we expected 1, because if b squared minus 4ac is 0, that means you're taking the square root of 0, which is 0, and plus or minus 0 doesn't give you any different number. It's the same number both times, right? Now, the last one, when it says less than 0, no real solutions, it doesn't mean that there's not solutions. It just means they're not real numbers that we can deal with anything that we've done up till now in this class. Right? We did learn in the prior section about solving by graphing, at least conceptually. What do we mean by that? To solve a quadratic equation by graphing, you graph the function, and then what do you look for on the graph? You look for where it crosses the x-axis, right? This is the graph when you've got b squared minus 4ac greater than 0. It means it's going to cross in 2 places. That's why you get 2 answers. Right. This is the graph when the b squared minus 4ac is 0. It means that the graph just touches the x-axis and then goes back in the same direction. That's why there's only 1 solution. It's actually the same number twice. And then this is the graph. This is the graph when your answers are not real. It means your graph never crosses the x-axis. And it doesn't mean, again, that there's no solutions. It just means they're not real numbers. So we got to come up with some other ways to do this. This was the number 45, the one that I had up there before, where all we had to do was evaluate discriminant and then say how many real solutions. If I followed that all the way through, right? Here's the quadratic formula. I get down to this step here. There's my discriminant, which we already said was -4, right? And we're stuck because what happens in your calculator if you try to take the square root of -4? Yeah, it's an error. What does it say specifically on the calculator? It says error, non-real solution, non-real, okay? Not meaning it's not a solution, just that it's not a real number. Okay, so we need a way to deal with something like the square root of -4, okay? Now, what part of that can we not do? I mean, if I split up the square root of 4 into the square root of -1 times the square root of 4, I can simplify the square root of 4. That's 2, right? It's the square root of -1 that I cannot simplify. So the way we deal with that is we define the square root of -1 as I. Okay, the lowercase letter I, which stands for imaginary. Okay? Lowercase letter I means imaginary numbers. And imaginary numbers, even though we're called imaginary, have real practical consequences. Even though you'd like to think that we're just torturing you with this, we're really not. It comes up in real life. You know, if we define I as the square root of -1, what happens when I square both sides? The square of a square root cancels each other out. You just get the -1. And then on the right, I squared. So I squared equals -1. I is the square root of -1. I squared equals -1. And we use that when we do operations with imaginary numbers. What time is it? I just, my background is in meteorology. And when I was at Penn State many years ago, and we were studying something that you can all understand, which is we know that we're heated by the sun, right? That's why the Earth is warm. So why is it that the sun is directly overhead at noon, but that's not the hottest temperature of the day? Why wouldn't you be hottest when the sun is shining on you most directly? And the reason is because the sun doesn't warm our atmosphere directly. Our atmosphere is transparent to sunlight. It shines right through and it hits the Earth because the wavelength is too short, right? The Earth absorbs the heat, and then the Earth re-radiates the heat, and that warms the atmosphere. That's why it's warmer down here than it is closer to the sun. Well, I was in a class that was called micrometeorology, where we were trying to determine, well, how much of a lag time should there be between the maximum sunshine and the maximum temperature? And that involved some very complex math, partial differential equations, that ended up having solutions that were involving something which you'll make a little bit of sense of this by the time we get to the end of this semester. But this is called e to the ix, which we can break down as cosine x plus I sine x, which cosines and sines are trigonometric functions which have shapes that look like that. And when you're trying to make a model that deals with temperature, that's a pretty good shape to have, right? Because we know that's what the temperature does. It goes up and it goes down, and it goes up and it goes down. And what we were able to determine by going through all this complex math involving imaginary numbers here and here, right, is that you should expect that 1/8 of a cycle after you get the maximum sunshine, you should get the maximum temperature. Now just think on a daily basis, what's 1/8 of a day? 1/8 of 24 hours. Three? Okay, it's really sad if we can't do 24 divided by 8 in our head. But the 3 hours. So just think, if the sun is directly overhead at noon, you would expect the maximum temperature at 3. In the summertime around here, it's daylight savings time, so you get the overhead at 1 and the maximum temperature at 4. Does that seem right? Do we get our hottest temperature of the afternoon is usually 3 to 4 o'clock? Yeah, that seems pretty good. Take it on an annual basis, right? What's 1/8 of a year, right? 12 months in a year divided by 8, 1.5 months, okay? Now, when do we get the most sunshine during the summer? What day is the longest day of the year? Say again? In the summer, the longest day of the year. Did you say December? The longest day of the year is June 21st, summer solstice. Is that the hottest temperature of the year? No, but add a month and a half, about 6 weeks. Now you're at the end of July, beginning of August. Is that generally when you get the warmest temperatures of the year? Yeah, pretty much. So when you model real world things with math, it doesn't always work out. But that one seemed to work out pretty well, even despite that it's using these things that we're calling imaginary numbers. Right? So there are real practical consequences to these things that we're calling imaginary. Okay, now when we do the same problem, right, the same problem that I had on the previous slide, and we get to this point right here where it says -4 plus or minus the square root of -4, we don't stop anymore. We can deal with the square root of -4. It's actually 2i, right? The square root of 4 part is 2. The square root of the negative is I, right? So we don't stop just because we get a non-real answer in the calculator. Okay, and then I can simplify that further just because the 2 divides into 4 and the 2 divides into 2. It actually ends up being this right here. -2 plus or minus I. Right, so we needed these imaginary numbers in order to solve a quadratic, and later polynomials for all their answers, not just the real answers, because they all have practical consequences. Okay, so now, like I said, real numbers are not the biggest set of numbers. Right? The biggest set of numbers is actually called complex numbers. Complex numbers are all the real numbers plus all the imaginary numbers. You put them all together, those are the biggest set of numbers, complex numbers. Right. Complex numbers are usually written in this form right here, right? A plus bi, where the a and b are just the real numbers. So it means you got two parts to a complex number. You got a real part, which is the a, and you got an imaginary part, which is the bi. That's called standard form. It's one of the SOL things we're supposed to know, that that's standard form. Right? Meaning, for example, 2 plus 3i is standard form. 3i plus 2 is not. Right? That's not standard form. Standard form, always write the real part first. Okay, so complex numbers are a plus bi. If the coefficient of I is 0, that means you got real numbers, because there's no I. And so real numbers are the complex numbers where the b equals 0. Imaginary numbers are the complex numbers where b does not equal 0. So would it be fair to say that all real numbers are complex numbers? Yes, right? So real numbers are a subset of the complex numbers. Would it be fair to say that all complex numbers are imaginary numbers? That would be a false, right? Because not all complex numbers are imaginary. Real numbers are not imaginary. The right way to say it would be all imaginary numbers are complex. I thought it was quiet in here. I see Sam's got his head down. That's why. I count on Sam to be answering these questions. Okay. Let's go. So we have to learn how to do operations with complex numbers. Now, we're going to do these by hand, and then I'm going to show you, you can do them in the calculator too. Okay, so I don't want you getting these kind of problems wrong just because you don't know how to use the tool. That's already in your hand. Okay, by all means, use it. When you add or subtract complex numbers, what you do is you add the real parts and you add the imaginary parts. You keep them separate. So in this example right here, where I'm adding 7 plus 3i and 5 minus 4i, when I say add the real parts, it means add the 7 plus the 5 to each other, because they're both real numbers. You can do that. And what do you get when you do that? 7 plus 5 is, please, you know that, don't you? 12. Right? Add the real parts, add the imaginary parts. And the imaginary parts, when you add them, it's like adding like terms, right? If I add 3i plus negative 4i, it's like adding x's, right? 3x plus negative 4x. You're going to get how many x's or how many i's in this case? 3 minus 4 is negative 1 minus I. Right? These are add the real parts. Add the imaginary parts. Okay, now let's see how you could have done that in the calculator and let the calculator deal with it. Okay, and this is how you're going to do it. So you should have your calculator out and be trying this. If you won't do that, then I can't help you. Okay. Now, really, when it comes to operations with imaginary numbers, all you need to know is one thing. Where's the I? And where is the I? It's on the decimal point right there. Look on your calculator above the decimal point, and you see the letter I, right? So if I want to put in this in the calculator, I can enter it just like it is. I'm going to use the parentheses even though it really doesn't matter for this particular problem, but let's just enter on the screen exactly what we see here, right? So that'll be parentheses, 7 plus 3, and now hit the second decimal point to bring up the I. Enter. And now we're going to go plus 5 minus 4i, plus parentheses, 5 minus 4 second I, and parentheses. Hit enter. 12 minus I. Right. It'll do that part for you. Now, if you were thinking that there was something else to do, and you might have because you've been in this before and you maybe have seen this, if you thought it wasn't going to work because we didn't change the mode yet, actually it does these operations. I didn't realize that either. I used to always say, you've got to change the mode to A plus BI. You really don't, right? This is where you've got to change the mode to deal with imaginary numbers. Try to take the square root of negative 4. Without changing anything else, just take the square root of negative 4. Second, square root negative 4. And hit enter. You get the non-real answer, right? Because we need I. Okay, so quit, hit quit, and then right to the right of the second button where it says mode, that's where you want to go. Click on the mode, and notice all the way down here, second row to the bottom, it says real, it's highlighted on real, but right next to it, there's the standard form of a complex number, A plus BI. So now, if I go down to that row and I highlight the A plus BI, and then hit enter, right? Now go back to the main screen and do the same thing, the square root of negative 4. Square root of negative 4 is 2i, right? So if you get non-real answers, make sure your mode is in A plus BI form. But if you're just doing operations with complex numbers like this, it really doesn't matter. It kind of treats the I like a variable at that point anyways. Try to do this one here, this 5 minus 3i plus 3 plus 5i minus 8 plus 2i. Do that in the calculator and just see what you get. See that you can enter all of that in correctly. Let me know if you get an answer. You get an answer? Are you trying this? No, it won't be the same. Did you take a calculator? Is that 21? So this is not going to work out any better in this class if you don't try, okay? And what answer did you get? It was 0, right? And it should have been, if you did everything right, you should have got 0. You could see it from here, right? 5 plus 3 minus 8, 0. Negative 3i plus 5i minus 2i, right? Everything's canceling out and you get 0. But if you got the 0, that means you at least, you know how to enter this stuff in the calculator. That was the right answer to get. So once you know how to do that stuff in the calculator, like all of the add, subtract, and multiply just become a matter of, could you put it in the calculator correctly? And I'm going to do this first one without the calculator to show, because that's my responsibility. But if you put it in the calculator, you could also see what you get at the same time I'm doing this. How is it that we usually multiply 2 things times 2 things? FOIL, right? FOIL is a way to make sure that you multiply everything in the first set of parentheses times everything in the second set of parentheses. In this case, the F will be 2 times 3, which is 6, right? The O will be 2 times 3i, which is, come on, 6i, right? The I will be 3 times negative 4i, negative 12i. And then the last, or sorry, yeah, actually I did the last already, that's okay. And now we're going to do the last multiplication. 2 times, negative 4i times 3i is, the negative 4 times 3 is negative 12, right? And then the I times I is I squared, right? When you multiply something times itself, you get I squared, right? But remember what we said in that first slide that we introduced the I. If I is the square root of negative 1, I squared equals negative 1. So we can replace that I squared with a negative 1. So this is 6. 6i minus 12i is minus 6i. And this is minus 12 times negative 1, which is 6 minus 6i plus 12, which is 18 minus 6i. Did anybody put it in the calculator to see what you got? 18 minus 6i, right? So if you when you multiply these things by hand, the thing that always throws us off is this I squared, right? The I squared, you got to replace it with a negative 1. That flips the sign. That gives you another real number to add to the first. Try this one here. Try the 4 plus 2i in parentheses squared. Should be, did you get it? 12 plus 16i. That is what you should be getting. 12 plus 16i. All right, so adding, subtracting, multiplying of complex numbers, we shouldn't get any of those wrong. There's always a few problems. That's all they're going to ask, right? Just do the operation. You got it in your hand, just do it. Should be no chance of getting it wrong. There is another part of it that working with complex numbers that we're really not required to do, which is the dividing part, right? The dividing part is really more to do with what you would call rationalizing the denominator, but that is specifically not part of the SOL. It says not to include rationalizing denominators. Now, there is one other part. There is one other part that the calculator that we're supposed to be able to do, and that is raise I to powers. And actually, what they expect you to do on this is to understand the pattern. Right? I to the first is I. Right? I to the first just means I squared, we've already said, is negative 1. I to the third, well, I to the third would be I squared times I. So that's negative 1 times I, which is negative I. And I to the fourth, well, I to the fourth would be I squared times I squared. But that's negative 1 times negative 1, which is 1. And you know, when I go I to the fifth will be I to the fourth times I, but I to the fourth is 1, so it's just I. We repeat the pattern, right? I, negative 1, negative I, positive 1. And they just keep going. As you count upwards, it just keeps going and going and going. And it's all based on multiples of 4. If I know that I'm raising I to a multiple of 4 power, then I know it's 1. It's always 1. I to the 48th is 1. If I know I'm raising it to an even power, which is not a multiple of 4, like 2, then it's negative 1. Right? If I raise it to a power which is 1 more than a multiple of 4, like 1 or 5, it's I. And if I raise it to a power which is one less than a multiple of 4, like 3, it's negative I. But you could put this in the calculator too, right? And if I put that in the calculator, let's see what it looks like. And I'm not 100% sure if mine is going to look exactly like yours. It's important that you try this, right? Let's try I to the 48th, right? Second I, and I raise it with the hat or the caret key, and I go 48. And I hit enter. Okay. And that looks confusing, right? 1 minus 2e negative 13i. That's scientific notation. That's saying 1 minus 2 times 10 to the negative 13th times I. Well, 2 times 10 to the negative 13th is 0.0000000000000. And then what was the rest of that? 2. And it was a 2. So then I come back to here, 2. It's all of that times I. That's the calculator not rounding off to 0. It's really 0. There is no I. The answer is 1, like I knew it was going to be 1. Here's how you get the calculator not to give you that E thing, right? If you go to in the calculator, go to Math and arrow over to the num, and then this number 3, I part, right? If I hit the I part, and now inside the parentheses, let me put the I to the 48th. Second, I raised to the 48th. That was wrong. Okay. And then it just gives me the 1. It does not give me that scientific notation at the end. Right? So if you're ever getting that, you know, it is, when you see 10 to the negative 13th, you got to think, okay, it just didn't round off to 0. But this fixes that. Right? This fixes any kind of operation you're doing that gives you that. Just put it inside the I part, fixed. So if this was 1, I mean, you could check by doing this in the calculator. I to the 62nd should have been negative 1. I to the 4001st was I to the 3999th was negative I. Again, if you put it in the calculator, math, num, 3, put it inside, see what you get. Okay, you're going to get some questions to solve in the homework, which are like this, right? It says, solve a quadratic equation, but there's actually only 2 terms. There's no x to the first, which means you really can solve it just by isolating the x, right? How am I going to isolate the x in this problem? Subtract 4, right? So I subtract 4, x squared equals negative 4. Okay, I have solved for the x squared now. How do I turn the x squared into an x? Take the square root of both sides, right? So in order to go from an x squared, you take the square root of both sides. Okay, on the left, the square root of a square is just the x part, right? And on the right, there's our square root of a negative number, which up until now, we would not have been able to do, right? Now we can do it. And the answer is close. Remember, it's plus or minus 2i. That is a fine point that we will see, especially like not the next chapter, but the chapter over. When you take a square root, you have to give the plus and the minus. If you were just presented with, on a test, if it said, what is the square root of negative 4? You would just say 2i. You would assume that they meant just the positive principal square root. But when you're solving an equation, you've got to get both the plus or the minus, or else you won't get enough answers. Okay. So try this one. Solve that, see what you get. Are you forgetting something? The plus or minus. What was the answers? Plus or minus 7i, right? So x squared equals negative 49. X equals plus or minus 7i. Now, if we have to solve a quadratic equation, if you're asked to solve a quadratic equation, you won't know necessarily, you probably will not know before you start whether you should expect imaginary solutions or not. You just have to go down the path. It may be, that you get 2 real answers. It could be you get the 1 real answer, or it may be you get the 2 imaginary. You just won't know until you've gone through it. I mean, the homework in this section obviously is geared towards you're going to get some imaginary solutions, right? But on a test, you wouldn't necessarily know that. So let's see. I'm going to just substitute into the quadratic formula for a is negative 3, b is 1, c is negative 3, and see what I get. Now, you could try to store in your calculator, right, the a, b, and c, and see what you get. A lot of times these answers end up being fairly confusing. They end up having like a ton of decimal places, so much so that you don't see that there's actually an I on the end of it because it's off the screen. So I'm not sure that the calculator is as good of a solution when you've got I's involved. But so I'll show it the long way. X equals b is 1, so negative 1 plus or minus the square root of 1 squared minus 4 times negative 3 times negative 3. Divided by 2 times negative 3. X equals negative 1 plus or minus the square root of 1, and what's going to come next? The negative 3 times negative 3 is 9, positive 9, right? 4 times 9 is 36. Right? If there had just been 1 negative there, then we would have been adding. But there's 2 negatives. The negatives times the negatives are canceling, and we're still subtracting. Divided by negative 6. Okay, x equals negative 1 plus or minus the square root of negative 35 divided by negative 6. Now, is there any simplifying we can do there? Can you simplify the square root of 35? I mean, 35 is not a perfect square. Its only factors are 1 times 35 and 5 times 7. No perfect squares here. So, no, you're not going to be able to do that. But what can you do about the negative, which is inside the square root? It comes out as a I. Right? So this is negative 1 plus or minus I times the square root of 35 divided by negative 6. Now, I would guess probably if you were looking at that in the book to see their answer, that would not have been their answer exactly. They probably would have said, this negative 1 over negative 6, the negatives cancel. So we can just make that plus. Now, you could only do that if you could also do it for this term here. But that's got a plus or minus, so it doesn't really make any difference. Right, so, this is the same thing as saying 1 plus or minus I times the square root of 35 divided by 6. The negatives cancel. Did anybody try to store for A, B, and C and run it that way? I mean, if you do that, you're going to get decimal answers, okay? And you can compare your decimal answers. If they had like a multiple choice question, you could see what their options were. You could turn their answers into decimals and see whether they're the same decimals as you got. I mean, that's one way to deal with it with your calculator. So try that one. When especially when we have the b is negative, we make a lot of mistakes with this thing right there. So you don't have to self-identify, but when you say -2 squared, remember that's +4. If you put it in the calculator and it said -4, that's because it wasn't in parentheses. Remember, a negative times a negative is always a positive. Good, Bree? Yeah. Okay. Well, we're almost done. Start to work. See what I can do to help. Come to tutoring. Do something. Okay. So if we go back to this chart, I mean, this chart is a little bit misplaced in the book now, and it's the new version of the book. They kind of changed things up because we didn't used to get to the quadratic formula until after we did imaginary numbers. So you did the imaginary solutions at the same time, and we never had a graphic here that said when the discriminant is less than 0, you expect no real solution. It said you expect 2 imaginary solutions. That's what it said. 2 imaginary solutions. But the rest of it is correct as it is. Okay, now if we look back at these, they're going to make a little more sense, right? Recognize that the square root of -1 is represented as I, right? The properties, basically the properties are things like commutative, associative, all the same properties we did on the first day of class. That's what they mean by that. They apply to complex numbers just like they apply to real numbers. Simplifying square roots, radicals, and ending up with something of the a plus bi form, standard form. Simplify powers of I to the power, whatever it is, right? Add, subtract, and multiply complex numbers, right? Now we know what they mean by that. Understand the sets, right? How these all sets work together. Complex numbers is the big set. Complex numbers are made up of imaginary and real, right? Real numbers are made up of rational and irrational, right? Rational numbers are made up of integers and whole numbers and natural numbers. I mean, now we've got like one layer on top of what we thought we already knew when it came to the numbers. And solve a quadratic equation over the set of complex numbers using an appropriate strategy. So now we've done them all. We can deal with any kind of quadratic equation, and we've got all the strategies that we're supposed to have to do it. Right, so next class, let's see, here's the homework. And the quiz next class is over. The 4-5 was solving equations. And at that time, really, it's going to be solving equations by factoring. And the 4-7 was quadratic formula. So it'll be solve equations by factoring and quadratic formula. Maybe answer some questions like, based on the value of the discriminant, how many real solutions do you expect? Right? It will not include any of the imaginary stuff because we just did that today, right? We won't have a chance to go over homework before we do that. And then we learn one more lesson in this chapter, which is graphing quadratic functions.